In this lesson, we are going to talk about similar polygons. Now, similar polygons we see in the world all around us, and you've been exposed to them just simply, for instance, when you look at a map on your phone, you'll see a picture of maybe your block or where someone is located or the map of the United States. That is a picture that's drawn to scale. So if I were to ask you to draw a diagram of a soccer field, you don't need a huge piece of paper to do that. You could use a convenient sheet, maybe an 8.5 by 11, or even a note card, and you can draw it to scale depending on the size of paper that you have. You show the right shape, but you do it in a convenient size. And that's what similar figures is all about. Two figures, such as the ones below, the stamps that I've shown, they have the same shape. They are called similar. Two polygons are going to be considered similar if their vertices can be paired so that corresponding angles are congruent and corresponding sides are in proportion, meaning their lengths have the same ratio. This is the only way that two figures can be similar. They have to follow these two very important rules. This is the definition of similar polygons. All of the corresponding angles are congruent and all of the corresponding sides are in proportion. You can't have one without the other. So what we'll do is we'll take a look at this picture of these two pentagons. When you refer to similar polygons, how you name them is very important. Their corresponding vertices must be listed in the same order. For instance, if polygon PQRST, so we're starting here at P, I'll just use a highlighter here and kind of go around so that you can see what I'm doing. We've got PQRST. So going around the pentagon, if we choose to name our pentagon starting with P and going counterclockwise, and it is similar to VWXYZ, it's very important that we write the names of the polygons in that same order. This is called a similarity statement. A similarity statement that's going to say polygon PQRST is similar to polygon VWXYZ. This little symbol here means is similar to. Is similar to. Very much like the congruent symbol without the equal sign, because not everything is congruent in the two similar figures, just the angles, the corresponding angles are congruent. So reading just from the similarity statement, I can start naming the angles that are congruent just by looking up here. P is going to correspond to V. That means that angle P is going to be congruent to angle V because angles are congruent in similar figures. Then we've got Q. Q is going to correspond to W. So we'll have angle Q is congruent to angle W. Now what allows me to write these statements, these congruent statements off to the right, is the fact that I've been told that these two polygons are similar to one another. Then we have R is going to correspond with X. So angle R is going to be congruent to angle X. We're running out of colors here. We have S corresponds to Y. So angle S is congruent to angle Y. And then we have T corresponding to Z. Angle T is congruent to angle Z. So there's all of our congruent angles. So corresponding angles are congruent. This is true of all similar figures. Corresponding angles are congruent. And then the second part of the definition is that their corresponding sides are going to be proportional. So we have PQ, P is the first, Q is the second, is going to correspond to the first and second letters listed in its similar polygon. So PQ over VW is going to equal QR would be the second and third letters, WX, second and third letters. So QR over WX. So the ratio of PQ to VW is going to equal the ratio of QR to WX, which will equal RS to XY. ST corresponds to YZ. And our last TP will correspond to ZV. TP will correspond to ZV. And this tells us that corresponding sides are proportional. So when I take each ratio and I put it in its simplest form, they will all be the same exact ratio in simplest form. So let's try an example. If two polygons are similar, let's move this down just a little bit. If two polygons are similar, then the ratio of the lengths of two corresponding sides is also called the scale factor of the similarity. So for instance, PQ over VW is equal to 20 over 32. So PQ is 20. It corresponds to VW, which is 32. All of these fractions will equal 20 over 32 in its simplest form. And when we take 20 over 32 and reduce it to its simplest form, it reduces to 5 over 8. So the scale factor of the similarity of pentagon PQRST to pentagon VWXYZ is 5 over 8. The similarity ratio, the scale factor of the similarity. Let's highlight that. The scale factor of the similarity of pentagon PQRST to pentagon VWXYZ is 5 over 8. The example that's going to follow shows a convenient way to label corresponding vertices A and A prime. So A will correspond to A prime, B will correspond to B prime, and so on. So here's our example. We have quadrilateral ABCD. It's the one on the left. ABCD is similar to quadrilateral A prime, B prime, C prime, D prime. So when an author or someone chooses to use the prime notation, it is safe to assume that A will correspond to A prime, B will correspond to B prime, and so on. So we have got two quadrilaterals that are similar to one another. Because they are similar, we can say that angle A is congruent to angle A prime, angle B is congruent to angle B prime, angle C is congruent to angle C prime, and angle D is congruent to angle D prime. We can also say that AB to A prime B prime is equal to BC to B prime C prime, which is equal to CD to C prime D prime, which equals DA to D prime A prime. And we want to know what their scale factor is. So what I'm going to do is I'm going to kind of fill in everything I know. I've got AB is labeled X. A prime B prime is 21. BC is 8. It corresponds to a length of Y. CD corresponds to C prime D prime, and DA corresponds to D prime A prime. Now, it wants us to find the values of X, Y, and Z, which are all side lengths. It wants us to find the scale factor of the similarity, the perimeters of the two quadrilaterals, and the ratio of the perimeters. So we'll start with the scale factor. I'm first going to fill in everything I know. So I'm going to start with X over 21. BC is 8 over Y equals 20 over 30 equals 10 over Z. Now you can do a quick check. We're looking at the similarity scale factor from the figure on the left to the figure on the right. So left over right equals left over right equals left over right equals left over right. So the left figure over the right figure equals the left figure over the right figure, and so on. Now all four of these fractions are going to be equal to each other. One of them has a numerical value, and that numerical value is 2/3 in its simplest form. So this right here is our scale factor. Of the figure on the left to the figure on the right. Now if I want to find X, Y, and Z, I'm going to take each one of those fractions and set it equal to the scale factor, which is 2/3. I cross multiply, and I get 3x equals 21 times 2. Now, many times, students will take 21 times 2, even adults, and make it a 42. But I'm going to, instead of multiplying, I'm just going to divide. And I know that there's a 3 in here. That's 3 times 7. So the 3's cancel out, and I have 7 times 2, which is 14. So now I know that x is equal to 14. I'm going to solve for y by taking 8 over y equals 2/3. I'm going to cross multiply. 2 times y equals 8 times 3. I divide both sides by 2, and y is equal to 12. Now we solve for z. 10 over z equals 2 over 3. 2z equals 10 times 3. Divide both sides by 2, and we get z equals 15. So we found the answers to the first two problems. We know that x is equal to 14, y is 12, and z is 15. So x is 14, y was 12, and z is 15. Now we're going to find the perimeters of the two quadrilaterals. So our perimeter of ABCD is equal to 14 plus 8 plus 20 plus 10. That's going to give us 20 plus 10 is 30. 30 plus 14 is 44. 44 plus 8 is 52. We'll find the perimeter of A prime, B prime, C prime, D prime. And it is equal to 21 plus 12 plus 30 plus 15. 30 plus 15 is 45. 45 plus 12 is 57. 57 plus 21, I believe, is 78. So there's our perimeters of the two quadrilaterals. I'm going to highlight that. So the perimeter of the two quadrilaterals, 52 and 78. And the ratio of the perimeters, is just going to equal 52 over 78. And I'm going to come over here and I'm going to break down 52. 2 goes into 52 26 times. And when you use this ladder method to prime factor, you'll find that you can cut things in half and a lot faster, and you'll add facts to your knowledge base. 78, 2 goes into 78 39 times. 3 goes into 39 13 times. So 2 times 3 times 13. Hopefully you can see without a calculator. This makes this very convenient. Our similar ratio perimeter ratio of the perimeters is 2/3, which is the same as the ratio of the scale factor. So the scale factor of similarity is 2/3, and so is the ratio of the perimeters. And that will be true on all similar figures. The scale factor is equal to the ratio of the perimeters. You go ahead and try the next problem. Hit pause on the computer so that you don't see the answer too soon. And when you're ready to check your answer, go ahead and hit play. Okay, we have our answers. A, I have angle y prime is equal to 70 degrees, and angle D is 90 degrees. The scale factor of Judy to J prime, U prime, D prime, Y prime, so I forgot a prime there, is 20 to 15, which is equal to 4/3. If I want to find DU, DU corresponds to D prime, U prime. It's going to equal the scale factor of 4/3. So I take 4/3, set it equal to du/6 because d prime u prime has a length of 6. You cross multiply and divide, so 4 times 6 divided by 3 gives me a value of 8. The ratio of the perimeters is quite simply the same as the scale factor, which is 4/3, and DUJY is not similar to Y prime, J prime, U prime, D prime, because this similarity statement shows that Y, angle Y, would have to be congruent to angle D prime. It's clearly not congruent to one another, as angle D prime is marked as a 90-degree angle, and angle Y is given to be 70 degrees. Corresponding angles must be congruent for the figures to be similar. So I hope that this lesson gets you well on your way to similar polygons, and have at it with the homework and bring your questions back and we'll go over them. Have a great day.